Assalamualaikum. Hi students. So today we're going to look at a new chapter which is multiple integrals. Now in this chapter we will look at double and also triple integration. So for the first part we are looking at the introduction and also the properties of double integration. Okay, now let's recall a bit what you've done in chapter 1. Now you are so used to this, yeah? So y equals to fx. So what do you understand about this? Now, which one is our independent variable? Our independent variable, that will be x. Alright? So, x is what we called the independent variable. So, y is also a variable, but that is a dependent variable. Okay? So, if I say differentiate that function, so you will give me dy by dx. That means you are differentiating with respect to x. Right? Since x is our independent variable. Right? You can also give me the notation as f prime. Yeah, it's understood it's differentiating with respect to x. Now let's say I have a function with two independent variables. Let's say x and y. Let's note that with z, for example. Now if I say differentiate that, you can have two ways, yeah, which is differentiating with respect to x or with respect to y, because we have two independent variables there. So you can either differentiate z with respect to x or differentiate z with respect to y. But since we are differentiating partially, therefore the notation is not d. Alright? So instead of d, we use del. So that would be del z by del x, alright, or del z by del y. That means we are differentiating with respect to the independent variables. Okay. Other notation that will be fx means we are differentiating with respect to x, or fy. Now, let's make an example here. So let's say I have fxy equals to 3x power 4 plus 2y. Now, if I say find del f by del x, that means we are taking x as our independent variable, yeah, and y will be taken as constant. Okay, so 3x power 4, that's 12x power 3. So y is a constant, differentiating is constant, you will get 0 here. So that will be equals to 12x cubed. Now, if I say using the same function, now find del f by del y. That means y will be taken as variable now and x will be taken as constant. So 3x power 4, x is a constant. So that will be 0 there. Plus 2y differentiating that, you will get equals to 0. So our answer is 2. So differentiating functions with more than one independent variables will depend on which variable you are referring to. Okay, so you've done this in chapter 1. So the same case with integration. If you are integrating one independent variable, that means you have to take other variables as constant. Okay, so these are the properties of double integrals. Now it's very similar to single integration. Okay, let's look at the first one. For constant multiple, all right, you can see, yeah, we have our constant c there. Let's look at use a different color. So we have a constant c there. Right? So according to the property, you can bring this c out. Okay. So hence we have that c out of the integration symbol. Now the second bit, the sum and difference. Okay. You have function f and g both in terms of x and y. You add both. Alright, you can split that because it's under the same integral. You can split that into two integration. Okay, so the third one is if f is bigger than 0, that means the integral of f will be bigger than 0 also. And part B stated that if f is bigger than g, therefore the integral of f will be bigger than integral of g. Alright. And the last property is additivity. Right? If we have integration under a region R, right? So that R, if we can split that into two, Yeah, if you recall, we did kesatuan, yeah, union there. If R is R1 union with R2, therefore you can split that into two integrals here. Okay, so let's do an example. So evaluating double integrals. Now, this is just very basic, all right? That is single integration. So let's look at the first one. That is integration with respect to x. That means x to be taken as variable. So integrating this, okay. So 3x squared, that would be 3x power 3 over 3 plus integrating x, that is x squared over 2. Now the method of integration, if you are still weak in method of integration, yeah, please do some revision on that. You have done quite a lot in calculus, okay? So please do revision on that, yeah? So integrating, we have that for the limits of 2 and 3. So the next step would be for you to insert the limits. Now please show your working so as that if you have your final answer wrong, you can still get marks for method. Alright, so what do I mean by that? Which is this. First we insert our value of 3. So that's going to be 3 cubed plus 3 squared over 2. That is for value of 3. Alright, take away 2 cubed plus 2 squared over 2. So calculating this, we have our value 21 and a half. So what I mean by the marks for method is, if you have your final answer here wrong, for example, you can still get marks for method at that stage. Okay, so it's always safe for you to show your working, yeah, however simple it is. Please show your working so that you will not lose marks for method just in case your final answer is wrong. Okay, second part, integrating exponent. Now, we are integrating with respect to y there. Okay, so integrating y, that is exponent to y, divided by 2 for the value of 0 and 1. So insert the value here. So now I have, let's just bring the half out there. So exponent 2 times 1, take away exponent 2 times 0. Hence, our final answer is half of exponent 2, take away 1. Okay, so those are our final answer. So what I'm doing here is just, I would like to express the symbols that if we are integrating with respect to x, therefore you will take x as your variable in this case. Yeah, if we are integrating with respect to y, therefore you have dy symbol there. Okay, now let's look at this example. If you look at example 1 and 2, both have the same function and they also have the same limits. Yeah, it seems like they have the same limits, but note here, the first one is integrating with respect to x, the second one is with respect to y. So let's do the first one. Alright, so we are integrating for the limit of 1 and 2. Our function is x cubed plus 4y. We are integrating with respect to x. Okay, now before that, let us do some calculation here. If I have, let's say I have x power 4 plus 3 dx, integrating that. Okay, here I have x power 5 over 5. Okay, 3 is a constant. Since it's a constant, we add one variable. So 3 times x between 0 and 1. Okay, so we find the answer here. That will be equals to 1 over 5 plus 3, take away 0. Alright, now let's do our example again here. So we are integrating x power 3 plus 4y with respect to x. Alright, so y will be taken as constant. So x power 3, that will be x to the power 4 over 4 plus 4y. 4 is a constant, y is a constant, so therefore you add one independent variable here. And in this case, it's x. Alright, so that is between the value of 1 and 2. Next, we insert the values. Now, where do we insert the values in? Is it in x or in y? Obviously, it's in x. Why? Because we are integrating with respect to x. So the value of 1 and 2 are values for x. Alright, so inserting that, now I have 2 to the power 4 over 4 plus 4y times 2. Okay, take away 1 to the power 4 over 4 plus 4y times 1. Alright, so solving this, I have 4 plus 8y, take away 1 over 4, take away 4y. Our answer is 4y plus 15 over 4. Okay, so let's do the same question, the same function, but now we are integrating with respect to y. Alright, okay, so part 2. So the same function here, x cubed plus 4y, but now we are integrating with respect to y. So since we are integrating with respect to y, that means our x will be taken as constant. Okay, let's integrate this. X to the power 3, x is a constant, alright? So just leave x to the power 3 as it is, alright? Since it's a constant, we add one independent variable, which is y. Okay, plus 4y, integrate that, that's going to be 4y squared over 2. Okay, so next we insert the values. So it's always safe for you to show the working, yeah? So inserting value of 2, so where do we insert 2 in? Now, we are integrating with respect to y, therefore the values of 1 and 2 are values of y. Okay, so we insert in y. So x power 3 times 2 plus 2 times 2 squared. Okay, take away x power 3 times 1 plus 2 times 1 squared. Okay, so our answer is going to be x power 3 plus 6. So you can see that even though the question is very similar, but we have different answers. Okay. Next, iterated integral. Now, iterated integral means you have more than one integration in one question, I could say. Alright, so look at the first two equations there. Now, if you look here, okay, for the first part, yeah, so it's dx there, right? Now, the limits for that x is a and b, right? For the outer limit, for the outer integral, which is with respect to y there, and that limit is c and d, right? So if you are doing your integration, you have to start with the innermost integral. That means you have to integrate the ones in the square bracket first, yeah, in pink, then only you integrate with respect to y. That's for the first one, all right? If you look at the second equation, okay, now dy is inside there. That means the limit for y is c and d, all right? Okay, for the outer limit, yeah, that's a and b. Now that is actually the limit for dx. So in this case, which one do we integrate first? It must always be the innermost integral. So you have to start with this. Once you have integrated that with respect to y, then you continue integrating with respect to x. You don't do it separately. Okay, so there's a note that solve the integration by expression in the square brackets first. All right. Okay. Now, what does the Fubini's theorem states? Okay. Now, ignore the integral equation there first. So let's look at the statement there. If f is continuous throughout the rectangular region, right, where r is defined by x between a and b, y between C and D. So the rectangular region is actually this, if you want to sketch that, yeah. Alright, let's say these are our axes. Okay. So let's say this is my y there. And that's our x. Alright. So the statement here, right, this statement there states that x is between A and B. So let's say this is A. Okay, that's A. And that's B. Alright. So that's A and B. Okay, and y is between C and D. Okay, between C and D. So where is our rectangular region R? So the region R would be bounded by these lines, and our area would be this. Alright? Okay, so that means if I am integrating, if you look at this part, yeah, that bit, I am integrating over the region R. That means we are integrating in that what do you call that? That region, yeah, between AB and CD. Okay, since all the values of A, B, C, D are constant, so Fubini's theorem states that there is no specific order of integration. Alright, so let me just make a note here. Okay. So what should I say there? Alright, so order of integration. So the order of integration is not important. Now what do I mean by that? Right, it means, yeah, if you look here, we can either do dx by dy or dy by dx. We can solve it both ways. Yeah? But please note, if I am integrating with respect to x, that means the limit there, the inner limit must be for x, which is a and b. Yeah? So look at the outer limit there, that is y. So the limit for y is c and d. Alright, the same goes with the other part. However, you have to solve starting with the innermost integral. Okay, let's look at this example. Okay, now the question is already given with the limits stated as that. Right? Can I change the order of integration? Right? So according to Fubini's theorem, I can change, instead of doing dy dx, I can change using dx dy. Why? Because all the limits here are constant. Right? So therefore, I can change that. Okay, let us just solve this. Okay, so our question is 1 over 4 minus 1. So that's 2x plus 6x squared y dy dx. Okay, so we have to solve the innermost integral. That means we have to solve with respect to y first. Solving with respect to y, your x will be taken as constant. Okay, so I am solving the one in the bracket, yeah? So this is the one in the bracket. Okay, now solving that, we still have to write integral for x out there. You cannot leave that out. Alright, now let's integrate with respect to y. So 2x, x is taken as constant now. So that will be 2x plus 1y. Okay, plus 6x squared y. X is a constant, so 6 and x squared are constant. Just leave it there. So integrating y, that will be y squared over 2. So these are for the values of between minus 1 and 2. So let's simplify this a bit. Okay, so now I have, so integrate 1 over 4, you still have to write that down. Okay, let me just put the red bracket here. Okay, so now here we insert the values of 2 and minus 1. Where do we insert that in? Now, we are integrating with respect to y. That means we have to insert into y. So 2x times 2 plus 3 x squared times 2 squared. Yeah, so this is inserting 2. So take away. Now we insert minus 1. So 2x minus 1 plus 3 x squared times minus 1 squared. Okay. Alright, so you must have your dx out there. Alright, so next bit, simplifying. So still we have to have our 1 to the power 4 of dx. So now this becomes 9x squared plus 6x dx. Okay. So integrating, that will be 3x power of 3 plus 3x squared. Right. Insert your values. Please show your working at this stage. 4 squared, take away 3 of 1 cube, take away 3 of 1 squared. Our answer is 234. Okay, so let's go back to our question. Right, so we are doing the order of integration dy dx. Now my question again, if we do dx dy, can we change the order of integration? Yes, we can. Why? Because here we have all limits as constant. Yeah, constant values. Alright, so please do, if I change the order of integration into dx dy. Alright, so changing dx dy, that means you have to change this, you have to switch this. Yeah? So what do you expect the answer is going to be? So the answer is going to be the same as 234. Alright, so please do this as an exercise. Okay, now last example. So evaluate the double integral for y squared x dA. That's our question over the rectangular region. Now R is given in curly brackets. Do you recall what does the curly bracket means? Right? If you recall, that means it's a set. Yeah. So R is a set of these coordinates. Yeah, the pair numbers x and y, whereby x are between -3 and 2, y between 0 and 1. Okay. So if you are given a question where R is in terms of this set, that means your limits will be constant. Okay. Now, let's do our integration here. So the question is, we integrate y squared x dA. Alright, we are integrating over the region R. So now you have to state your order of integration. So it's either dy by dx or dx by dy. It's up to you. Alright, so let's say I want to do the order as, yeah, so y squared x, that function. Let's say my order of integration is dx dy. Okay, so let me just put here, we have to solve the innermost integral. Yeah, so that will be the limits of the inner integral, that will be the values of x. Right, so now x is between -3 and 2. So for x between -3 and 2. For the outer limit, yeah, for y, so y is between 0 and 1. Alright, so our limit for y is between 0 and 1. So you solve starting with the innermost integral. Yeah, but still you have to write the outer integral here, 0, 1 and dy. Okay, let's integrate that. So y squared x, we are integrating with respect to x. That means our y will be constant. So y is a constant, so just leave y squared as it is. Integrating x, I have x squared over 2. So this is for the value -3 and 2. Okay, so let's insert the value there. So we insert 2n minus 3 into x. Okay, so here I have 2 squared over 2 times y squared, take away minus 3 squared over 2 y squared. Okay, so simplifying, so this is going to be equals to minus 5 over 2 y squared dy. So from this onwards, I don't expect you to have problems. Okay, so let's bring the constant out, minus 5 over 2. So I am only integrating the function y squared. That's going to be minus 5 over 2 y to the power of 3 over 3 between 0 and 1. So we insert the value, which is equals to minus 5 over 2, 1 over 3 take away 0. So our answer is minus 5 over 6. Okay, so as I mentioned just now, we are solving with the order of dx dy. So if we change the order into dy dx, we will still get the same answer. Alright, so as an exercise, change the order of integration. So let's just write here, an exercise, change the order of integration and solve. Okay, so when you solve that, you will get the same answer, which is minus 5 over 6. Okay.